With the conditional statement, there are some related statements. Conditional and related statements. Here's what I mean by that. Let's say we have a condition. Going back to conditional statements now. If I study, then I make an A. Okay? Start with that statement. Well, I can switch that around, for example, and say, if I make an A, then I study. That's the kind of thing we are talking about is somehow adjusting or changing up the conditional statement to make it ever so slightly different. If I make an A, then I study. For one example. Well, that so happens to be what I did there was I flip-flopped the roles of the P and the Q, right? I made the I study part the then part, I made the I make an A part the if part. Well, if you do that, that is called what is known as the converse. The converse, and the way I describe it is, you flip the if and the then part. So the converse flip will do the flip of the if part and the then part. Okay? Okay? All right. Well, another way, another related statement is if you negate both parts. So say I do an if I don't study, then I don't make an A statement. That's called the inverse. So what did I do to do the inverse there? I negated both parts. The inverse negates both parts. The order stayed the same, right? But I negated both parts. I negated the I study part. I negated the make an A part. That's called the inverse. The last one does both. It flips and negates simultaneously. So what would that be? If I don't make an A, then I didn't study. Or I don't study. That's called the contrapositive. Long word. So the contrapositive both flips and negates. All right, so the converse flips. The inverse negates. And the contrapositive flips and negates it. Those are related statements we're talking about. All right, so let me rewrite this in kind of notationally. All right, so let's say we've got a if P then Q statement. Converse of it. What would the converse if I do it that? Well, the converse, the if part becomes the then part becomes the if part, so that would be if Q then P. That's the converse. Flips. what would be the inverse of this statement? Well, the inverse negates if not P, then not Q, is the way that one would come out, notationally anyway. And just a quick word on keeping these straight, because in the past I've had students have difficulty remembering which one or calling the inverse. But see, it's an inverse and negates, in. Kind of remember that. Inverse negates, in and in. Okay. Converse flips. All right, then the contrapositive, usually it's pretty easy to remember, because what do you do there? You do both. It's the longest word. It does both things. It flips and negates. So with this statement, it's if not Q, then not P. All right, so that's our summary of those things. Okay? So it'll ask you to do converse and inverse and contrapositive of a whole bunch of several statements in the homework. Okay? The other part, though, to this is deciding or knowing which one of those statements actually says the same thing as the original. Turns out only one of these, the converse, the inverse, and contrapositive, says the exact same thing or means the exact same thing as the original statement. So that's my next consideration. Which one is the same or equivalent to the original? There's only one of them, I'll tell you that. Maybe. How do we know, though? How could we know? Well, the way we're going to know is, we talked about negations being exactly opposite. Well, if it's the same or equivalent is, it means exactly the same truth table. So that's what we're going to look at. We're going to look at the truth tables for all these and see which ones are exactly the same. That's equivalent in logic. They have exactly the same truth tables, okay? So that's the question we're going to look at. Which one has the same truth table? That's how we'll prove this. And see if you're right, okay? So let's look at the truth table for each one, and we'll do it as compactly as we can. It shouldn't take us too much space here. 4 lines. All right. So yeah, we're going to do a truth table for the original statement. So it's just a P's and Q's. So it's true, 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 false, false, true, false, false. So the original statement is if P, then Q, P arrow Q. And as we know, arrow, how does it work? The only time the arrow is false is if what? T arrow F. So the first one we got T arrow T, that's true. T arrow F, that's the false one. F arrow T, though, is true, because it's T arrow F that's false. F arrow T is true. And then F arrow F, what's F arrow F? That's also true, yeah. It's a little tricky there, but F arrow F is true. So that's what we're looking for. We're looking for an equivalent truth table that has T, F, T, T in that order. All right, well, let's try the converse. Converse flip, so I'm just going to flip. That'll be Q arrow P. And I'll go ahead and write, I didn't write them on that one, but the component statements, Q is true, false, false. P is true, true, false, false. All right? So what have we got as far as truth values are concerned? Well, we got T arrow T. That's true. F arrow T. True or false? F arrow T. That one's true. T arrow F is false. That order is false. And then F arrow F, true. Okay? So we wind up with the converse being TTFT. Does that match up? Almost, but not quite. We're trying to match the original, exactly. So it's got to be TFTT. This is TTFT. No, not a match. It has 3 trues and a false, but they're in a little different order, aren't they? They need to be exactly the same order. So converse is not equivalent. What about the inverse? Well, the inverse negates inverse gates. Okay, negates. All right, so we negate not P, arrow not Q. That's what the inverse does. So the not P would be false, false, true, true down the line. The not Q would be false, true, false, true. And we arrow those together. False arrow false is true. False arrow true is true. T arrow F is false. And T arrow T is true. And again, comparing to the original, not quite the same, is it? Well, if one of them is going to be equivalent, we're down to the contrapositive, our last hope. Contrapositive flips and negates, so that would be not Q, arrow, not P. Right? We flip it and negate it. So not Q is false, true, false, true. Not P is false, false, true, true. False arrow false is true. True arrow false is false. False arrow true is true. And true arrow true is true. Hey, how about that? We did find one. Yeah, turns out equivalent to the original statement is contrapositive. It will always be the case. Those two things say exactly the same thing. Always will be. All right? So for a conditional statement, its contrapositive is always equivalent. It says exactly the same thing. Okay? So that's what you need to remember. Now, let me give you an example here or two. All right? Let's say I had the statement, if I get sick, then I go to the doctor. If I get sick, then I go to the doctor. All right? Let's write an equivalent statement to that. In other words, using the same expressions, the same statements, but different order, so to speak. How could I write that equivalently? Well, to write that equivalently, slightly phrased differently, write as contrapositive. What would the contrapositive of that be? Well, the contrapositive flips and negates, so the equivalent statement would be if what? Well, I flip it and negate it. So this part comes up. So if I don't go to the doctor, and negate. So if I don't go to the doctor, then what? I don't get sick. It says exactly the same thing, doesn't it? Yeah. It says exactly the same thing. It's contrapositive. Just rephrase it. Okay? All right, here's a similar problem, a little different version. All right, if it is a natural number, then it is a counting number. I mean, if it is a natural number, then it is an integer. That's what I meant to say. If it is a natural number, then it is an integer. Okay? Which is equivalent to that? A. If it is not a natural number, it is not an integer. If it is an integer, B. If it is an integer, then it is a natural number. Or C, if it is not a natural number, no, C, let me start that again. If it is not an integer, then it is not a natural number. Okay, let's write those down for a second. A is if it is not a natural number, it is not an integer. B is if it is an integer, then it is a natural number. And then C, if it is not an integer, then it is not a natural number. Any of those equivalent? None of those equivalent? What do you think? Well, the key is you don't want to kind of overanalyze this or anything. Now, what I'm asking you for here, since this is a conditional statement, and I'm asking you for an equivalent statement, I'm looking for what? Well, close. It needs to be the contrapositive, doesn't it? Because that's what we know. The converse and the inverse are not necessarily going to say the same thing. We're looking for the contrapositive because we know the contrapositive is equivalent. If I'm looking for this conditional statement equivalent, I'm going to look for its contrapositive. And the contrapositive does what? It flips and it negates. So is A the flip and negate? Nope, it's just the negate, right? Same order, but it is the negation. I need the flip in there. B is just the flip, isn't it? It flipped them, so that's not the contrapositive. What about C? C is it, isn't it? Because that both flips it and negates it. Contrapositive. Contrapositive is always equivalent to the original statement. So that's what you want to do on those. Okay? If it asks that for that way.